Hello and welcome back. In today's video, we're overclocking the Intel UHD Graphics 730 integrated in the Core i5-12400 processor all the way up to 1800 MHz using the ASUS ROG Z690 Extreme motherboard and a Thermalright air cooler. This will be more of a shorter overclocking video than usual, as it's more like a supplement to my Alder Lake non-K overclocking video, SkatterBencher number 37. As I still have the CPU on hand, I wouldn't be a SkatterBencher if I wouldn't also try and overclock it. Anyway, it will be a shorter video, but I hope you still enjoy. Let's get into it. The Intel UHD Graphics 730 is the integrated graphics of the Alder Lake non-K Core i3 and Core i5 processors. It's identical to the integrated graphics available on the Rocket Lake Core i5 11400 processor, and thus also features the Intel XELP microarchitecture. Well, nearly identical, as Alder Lake uses a smaller process node and has slightly elevated graphics frequencies. I already overclocked two Intel XELP integrated graphics products before, the UHD Graphics 750 of the 11900K in SkatterBencher number 28, and the UHD Graphics 770 of the 12900K in SkatterBencher number 33. While all three models feature the XELP graphics architecture introduced during Intel's 2020 Architecture Day, some minor differences exist. Most obviously, the UHD Graphics 730 only has 24 execution units instead of the 32 included in the high-end variants. The default power consumption of the UHD 730 is also about half that of the UHD 770. Also, the maximum boost clock for the slice and unslice is reduced by about 100 MHz from the UHD 770, though the slice clock is 150 MHz higher than the Rocket Lake UHD 750. Regardless, our performance expectations are not very high. In this video, we will cover 4 overclocking strategies for the UHD Graphics 730. First, we enable ASUS multi-core enhancement and Intel Extreme Memory Profile 3.0. Second, we increase the frequency with the conventional BCLK overclocking restrictions in place. Next, we use Alder Lake non-K base clock frequency overclocking to further increase the graphics frequency without increasing the voltage. Lastly, we push the integrated graphics as far as we can by increasing the voltage. While I will still try to provide you with more than sufficient information and context so you understand how to overclock a non-K integrated graphics, I won't get into the nitty-gritty details. For that, I would like to refer you to SkatterBencher number 33 and number 37, where I overclocked the UHD 770 integrated graphics and the non-K Alder Lake processors already. With this in mind, before we get started, let's first have a look at the hardware and the benchmarks that we use in this guide. Along with the Intel Core i5-12400 processor and its Intel UHD Graphics 730 integrated graphics, in this guide we use an ASUS ROG Maximus Z690 Extreme motherboard, a pair of 16GB AORUS DDR5 6200 Hynix memory sticks, a Kingston SSD Now V300 120GB SSD, a Cooler Master V1200 Platinum power supply, and Thermalright Assassin Spirit 120 Tower heatsink. All this is mounted on top of our favorite open bench table V2. The cost of the components should be around $2,600. I know the motherboard isn't a segment nor a price match for this CPU. However, the point of this video is to explain to you how non-K integrated graphics overclocking works, not help you decide whether it makes sense from a value for money perspective. Spoiler alert, it really doesn't. We use Windows 11 and the following benchmark applications to measure performance and ensure system stability. As you can see, the benchmarks are pretty different from what we usually use. I already covered how I use AI benchmark using TensorFlow DirectML and Handbrake using QuickSync in SkatterBencher number 28, where I overclocked the UHD Graphics 750. I use the same methodology for this guide. Before we start any overclocking, we have to check the performance at default settings. Please note that the ASUS ROG Maximus Z690 Extreme motherboard enables ASUS multi-core enhancement out of the box. So if you want to check the performance at default settings, you first have to go into the BIOS and enter the Extreme Tweaker menu. Set ASUS multi-core enhancement to disabled, enforce all limits, then save and exit the BIOS. Here's the benchmark performance at stock. When running Furmark GPU stress test, the average GPU slice clock is 1450 MHz and the GPU unsliced clock is 1250 MHz with 0.93 volts. The average memory clock is 2400 MHz. The average GPU temperature is 38 degrees Celsius and the average GPU power is 7.48 watts. In our first overclocking strategy, we simply make use of ASUS multi-core enhancement and Intel Extreme Memory Profile 3.0. ASUS multi-core enhancement is a single BIOS option that removes all the limits constraining the Turbo Boost 2.0 algorithm. Effectively, it allows you to run at maximum boost frequency indefinitely. Intel Turbo Boost 2.0 technology allows the processor cores to run faster than the base operating frequency if the processor is operating below rated power, temperature, and current specification limits. The ultimate advantage is opportunistic performance improvements in both multi-threaded and single-threaded workloads. Turbo Boost 2.0 ensures proper distribution of the available power budget among the CPU and graphics cores depending on the workload. So if you have a heavy graphics-dependent workload and no CPU load, it will decrease the CPU frequency and boost the graphics frequency higher. Of course, knowing that the power budget of this Alder Lake integrated graphics, the UHD Graphics 730, is only 7.5 watts, we don't expect this unleashing of the Turbo Boost to power limits to play any significant role in the performance uplift. Intel Extreme Memory Profile, or XMP, is an Intel technology that lets you automatically overclock the system memory in order to get better system performance. It's an extension to the JEDEC standard that allows memory vendors to program different settings onto the memory sticks. Intel Extreme Memory Profile 3.0 is the new XMP standard for DDR5 memory. It is based mainly on the XMP 2.0 standard for DDR4, but has additional functionality. I won't discuss the details of XMP 3.0 here, as that falls outside of the scope of this overclocking guide. If you're interested in more information about XMP 3.0, feel free to check out my Alder Lake launch video. However, what's important to note is that the Intel integrated graphics relies exclusively on the system memory for its performance. We saw a significant uplift in performance on previous platforms like Rocket Lake when running higher memory frequency. With Alder Lake, it's the first time that we pair an integrated graphics with DDR5. DDR5's main benefit is higher memory bandwidth and higher memory frequencies. Both of them should help us get better out-of-the-box performance than with DDR4. Upon entering the BIOS, enter the Extreme Tweaker menu. Set AI Overclock Tuner to XMP1. Set ASUS Multi-Core Enhancement to Enabled Remove All Limits. Then save and exit the BIOS. We rerun the benchmarks and check the performance increase compared to the default operation. As we saw with the UHD 770 graphics, increasing the memory frequency using XMP doesn't do that much in terms of performance uplift. We see a maximum performance increase of only 2.52% in Unigen superposition. When running Furmark GPU stress test, the average GPU slice clock is 1450 MHz and the GPU unsliced clock is 1250 MHz with 0.929 volts. The average memory clock is 3100 MHz. The average GPU temperature is 39 degrees Celsius and the average GPU power is 7.58 watts. Now we move on to the actual overclocking. I assume that anyone who's watching this video is already familiar with how Intel segments their CPUs and their chipsets. Essentially, if you want to do overclocking, you need a CPU and a chipset that is enabled for overclocking. On the CPU side, it means that you need a K or an X CPU. On the chipset side, you need an X or a Z motherboard. The main difference between these unlocked parts enabled for overclocking and the locked parts is that on unlocked parts, you typically have access to multiplier ratios for different parts inside your CPU that are higher than the default maximum ratio. On locked parts, you don't have access to those higher multipliers. Furthermore, on locked parts, you also have an artificial limitation of the BCLK frequency to 103 MHz. That means that effectively you're restricted to running these CPUs up to 3% higher than the default specification. In our second overclocking strategy, we overclocked the UHD Graphics 730 using BCLK frequency overclocking, however, with the conventional restrictions in place. By conventional restrictions, I'm referring to a specific feature on Intel CPUs that controls the BCLK frequency. In 2015, Skylake introduced a new feature called BCLK Governor. The BCLK Governor is an integrated circuit that calculates the BCLK in real time and issues a machine check error if BCLK is higher than the allowed limit. Since Skylake, the maximum permitted BCLK frequency on locked non-K CPUs is 103 MHz. Upon entering the BIOS, enter the Extreme Tweaker menu, set AI Overclock Tuner to XMP1, set BCLK frequency to 102.9, set ASUS Multicore Enhancement to Enabled Remove All Limits, then save and exit the BIOS. We reran the benchmarks and checked the performance increase compared to the default operation. Up until this point in the video, we've used performance tuning options that should be available on any Intel 600 series motherboard. Therefore, the performance increase is very much the definition of free performance. We see a maximum performance uplift of plus 6.97% in Final Fantasy XV. When running Furmark GPU stress test, the average GPU slice clock is 1492 MHz and the GPU unsliced clock is 1286 MHz with 0.928 volts. The average memory clock is 3189 MHz. The average GPU temperature is 43 degrees Celsius, and the average GPU power is 7.95 watts. In our third overclocking strategy, we will finally use the Alder Lake non-K BCLK overclocking features to increase the frequency of the integrated graphics. However, for now, we stick with the default operating voltage. I extensively covered the non-K Alder Lake CPU overclocking in SkatterBencher number 37. In short, non-K Alder Lake CPU overclocking is possible due to an apparent oversight in a pre-release very early Alder Lake CPU microcode. In this microcode, a specific feature of the CPU power control unit is not working correctly. That feature is called the BCLK Governor. On the specific non-KOC microcode, the BCLK Governor works correctly for the integrated clock generator, but not for the external clock generator. Using this CPU microcode in combination with an external clock generator means you can increase the base clock frequency on a locked, non-overclockable part beyond the artificial limitation of 103 MHz. The ASUS ROG Maximus Z690 Extreme motherboard 0801 BIOS comes with two microcodes. The latest version, which when the BIOS was released was version 15, and the non-K BCLK enabled 0x9. By enabling the Unlock BCLK OC option, the BIOS will load the 0x9 microcode. If this feature is disabled, it will load the latest microcode. Just as a reminder, while on microcode 9 we have access to essentially unmonitored BCLK overclocking for our non-K Alder Lake processors, it doesn't mean that we have access to many of the advanced overclocking tools that are available in K-SKU processors. So while we can do overclocking, we still have a lot of restrictions in place that might make it a little bit more difficult to do overclocking for a daily system. I extensively covered the ins and outs of Alder Lake integrated graphics in both my Alder Lake launch video and SkatterBencher number 33. Essentially, the integrated graphics comes with three different segments: the slice, the unslice, and the display block. The slice is a cluster of subslices, each of which contains the actual graphics compute engine elements like the execution units. The slice is the part of the integrated graphics that powers your games and any compute tasks. The unslice holds the elements with fixed function geometry capabilities and fixed function media capabilities. So if you're encoding or decoding a video or simply watching Netflix, this part ensures proper video encoding. It also contains the connection to the ring bus via which the IGP can send and receive data from the system memory. The display block contains support for the display outputs like HDMI or DisplayPort. When it comes to the clocking, the base clock frequency or reference clock drives the graphics frequency. By default, the BCLK is 100 MHz, but it can of course be increased when overclocking. For the integrated graphics, the base clock frequency is first halved, then multiplied by the graphics ratio to obtain the final operating frequency. Unlike Rocket Lake, on Alder Lake, the slice and unslice are decoupled. That means they're running at different frequencies. However, like on Rocket Lake, we control only the slice frequency using the graphics ratio. While on Alder Lake CPUs, the maximum graphics ratio limit is 42, since we are using a locked non-K processor, our highest available graphics ratio is 29. That means we can increase the frequency only via BCLK overclocking. Note that a separate fixed clock frequency drives the display output and is therefore unaffected by BCLK frequency changes or the graphics ratio. As you can see, increasing the base clock frequency will affect many parts inside our CPU. So in addition to increasing the BCLK, we'll also have to make other changes to our multiplier ratios to make sure that all parts inside the CPU are still functioning stably. Upon entering the BIOS, enter the Extreme Tweaker menu. Set AI Overclock Tuner to XMP1. Set BCLK frequency to 113. Set ASUS Multicore Enhancement to Enabled Remove All Limits. Set DRAM frequency to DDR5 6102 MHz. Set Performance Core Ratio to Sync All Cores. Set All Core Ratio Limit to 40. Enter the Tweaker's Paradise submenu. Set Unlock BCLK OC to Enabled. Leave the Tweaker's Paradise submenu. Set Max CPU Cache Ratio to 40. Set Max CPU Graphics Ratio to 29. Set CPU Core Cache Voltage to Manual Mode. Set CPU Core Voltage Override to 1.2. Then save and exit the BIOS. We reran the benchmarks and checked the performance increase compared to the default operation. We can improve the frequency by about 13% without increasing the graphics voltage. The unsliced portion of the integrated graphics is the main overclocking limitation, as it will quickly fail the handbrake benchmark. The performance scales pretty much linearly with the increased frequency. We see the highest performance increase of plus 14.51% in CSGO. When running Firmark GPU stress test, the average GPU slice clock is 1683 MHz and the GPU unsliced clock is 1413 MHz with 0.922 volts. The average memory clock is 3051 MHz, the average GPU temperature is 45 degrees Celsius, and the average GPU power is 8.62 watts. In our fourth and final overclocking strategy, we will push the graphics frequency a little bit higher with the help of additional voltage for the IGP. In my Alder Lake launch video, I extensively covered the Alder Lake voltage topology. From the voltage perspective, Alder Lake resembles Rocket Lake much more than Tiger Lake. Alder Lake transitions away from using fiber for the cores, ring, and integrated graphics compared to Tiger Lake. Instead, Alder Lake uses power gates. However, unlike Rocket Lake, some parts of the Alder Lake CPU are powered utilizing fiber. If we only consider the Alder Lake CPU and disregard the chipset, there are 7 different voltage inputs. The one relevant for overclocking the UHD Graphics 730 is called the VCC GT. This voltage powers the GT or integrated graphics, including the slice and unslice. The voltage rail supports both override and adaptive voltage mode. In override voltage mode, the voltage will remain constant. When using adaptive voltage mode, the graphics voltage will dynamically change depending on the workload. When overclocking and using adaptive voltage mode, the CPU will interpolate the required voltage for a given frequency between the base frequency and our set maximum frequency. Typically, you can set the adaptive voltage directly. The adaptive voltage maps against the configured boost frequency. Alternatively, you can use a global adaptive voltage offset, which offsets the entire voltage frequency curve. In this case, we're using a voltage offset of 350 mV, which increases the maximum graphics voltage from 0.9 volt to 1.24 volt. This allows us to further increase the slice and unslice frequency to 1800 MHz and 1550 MHz. Again, we are limited by the unslice frequency. Upon entering the BIOS, enter the Extreme Tweaker menu. Set AI Overclock Tuner to XMP1. Set BCLK frequency to 124.15. Set ASUS Multicore Enhancement to Enabled Remove All Limits. Set DRAM frequency to DDR5 6210 MHz. Set Performance Core Ratio to sync all cores. Set All Core Ratio Limit to 36. Enter the Tweaker's Paradise submenu. Set Unlock BCLK OC to Enabled. Leave the Tweaker's Paradise submenu. Set Max CPU Cache Ratio to 36. Set Max CPU Graphics Ratio to 29. Set CPU Core Cache Voltage to Manual Mode. Set CPU Core Voltage Override to 1.2. Set CPU Graphics Voltage to Offset Mode. Set Offset Mode Sign to Plus. Set CPU Graphics Voltage Offset to 0.35. Then save and exit the BIOS. We reran the benchmarks and checked the performance increase compared to the default operation. Unsurprisingly, further increasing the graphics frequency translates into a further performance increase. The scaling is still near linear, and we see a maximum performance increase of plus 29.48% in AI benchmark. When running Firmark GPU stress test, the average GPU slice clock is 1800 MHz, and the GPU unslice clock is 1552 MHz with 1.24 volts. The average memory clock is 3103 MHz. The average GPU temperature is 56 degrees Celsius, and the average GPU power is 15.30 watts. Alright, let's wrap this up. As I mentioned in the beginning of my video, this piece is more of a supplement to the SkatterBencher number 37, where I overclocked the non-K Core i5 12400 Alder Lake processor. While I still had the CPU on hand, I figured why not have a look at overclocking the integrated graphics as well. The overclocking experience of the UHD Graphics 730 is a combination of what we went through in SkatterBencher number 33, where I overclocked the UHD Graphics 770, and SkatterBencher number 37, where I overclocked the 12400 non-K processor. The main limitation of integrated graphics overclocking on Alder Lake is still the unslice frequency. Just like what we saw on the UHD 770 with the 12900K Alder Lake, and actually also the UHD 750 in the 11900K Rocket Lake, the unslice frequency is limited to about 1500 to 1550 MHz. The main problem that we face is essentially not having a ratio for the unsliced frequency. We can't adjust that frequency neither up nor down. So once we push it with the BCLK to the limit, that's all. There's nothing much more that we can do. In terms of the slice portion, we are also able to overclock it quite easily to 1.8 GHz. And that's not really a surprise, because as we demonstrated with the UHD 770 in SkatterBencher number 33, the integrated graphics of Alder Lake can overclock extremely well. With that UHD 770, we actually got all the way up to 2.3 GHz. In the end, when it comes to overclocking the integrated graphics of a non-K Alder Lake CPU, the main issue that I see is that you need a motherboard with both an external clock generator and that has a BIOS with this pre-release microcode. You likely will end up paying a premium for either one of those features, and I'm not quite sure that paying a premium for the ability to overclock non-K integrated graphics is really worth it. In the end, I got about 25% performance uplift, but this integrated graphics is still extremely slow. Anyway, that's it for today. As I said, this was a short piece that I was able to put together in, I think, about 2 days or something like that. So really a quick kind of an overclocking video. I'm still working on a couple of exciting overclocking videos, one of which covers this CPU that's in the system right here. It's an AMD CPU, so I guess you can probably figure out what CPU that is. So feel free to subscribe if you like more overclocking content. I'd also like to thank my one Patreon supporter, Coffee Penbit, for supporting my work. For those who want to have a closer look at my results or read through the BIOS settings, I will also have a written version of this video guide up on my blog. As per usual, if you have any questions or comments, feel free to leave them in the comment section below, and till the next time.